Okay, hiya year 8. So we are going to be looking at the uses of electromagnets today, and in particular we're going to be looking at the electric bell, and it's the big example that we need to know about, but you may have to put your use of electrical circuits and magnetism together in unfamiliar situations to do with electromagnets. But this process of looking at this circuit that we're going to be looking at today, you'll be able to apply that to other situations hopefully, and figure things out. So that's obviously a big skill that we need to be looking at. Okay, now the electric bell is just like, do you know the bells that would be in school that ring at the end of every lesson? One of those would just be an electric bell, and we're going to look here at the circuit that is involved and make sure that we understand what's going on in it. Okay, so this is just an electrical circuit, and it's a really good example of putting to use our knowledge of electrical circuits and our knowledge of magnetism, in particular electromagnetism. So let's have a little look here. So we have our power supply, and then we have our lead coming along down round here, and our wire is just wrapped around a bit of iron. Now when there is current flowing through this wire which is wrapped around the bit of iron, then that's going to turn into an electromagnet. But it's important to realize that that only happens whenever the current is flowing through that wire. Whenever there's no current flowing, this is just a bit of iron and a bit of wire. Okay, so it only turns on to be an electromagnet, or electromagnet can also be called a solenoid, only whenever the current is flowing in it. And obviously we all know it has to be iron, because iron loses its magnetism easily, which means that our electromagnet can get switched off. If we use steel, it is used more for permanent magnets, so this wouldn't work with steel. It has to be iron. So anyway, our wire comes down around here, wraps around the bit of iron, and then comes along here and down here. Now in terms of our circuit, then, so here's the flow of our current coming down around here, and then because this is a screw, it's metal, it's a conductor, the current can flow through it as well, so it can flow across here and back up. And then we have our switch, which makes or breaks the circuit. Now back to this little area here. This here is just a bit of springy metal, and it's important that it's springy, and you'll see why, which has this part of it which is currently in contact with that screw, but it's also attached to this bit of iron, again important, which has the hammer attached to it and the gong. So it's these two bits together that make the noise of the bell. Now at the minute we do not have a full circuit because the switch has not been pressed. So at the minute the circuit is just going to sit like this. Now I know there's like an ever so slight gap in there, but at the minute this is drawn as if these two are touching each other. Now let's think what's going to happen whenever we press that switch. So if I press that switch, I now have a full circuit, and having a full circuit means that current can flow. And if you remember, when we were saying that when the current can flow down around here, we have current flowing in a wire which is wrapped around a bit of iron, which makes an electromagnet. So as soon as this switch is pressed, this electromagnet gets turned on and it attracts over this bit of iron. Now whenever that happens, this comes over towards here, the hammer hits the gong, which makes a noise, but this little bit here at X, because that's attached to this, it moves away from the screw, and that means there's now a gap in our circuit. And as soon as there's a gap in the circuit, we all know that current cannot flow anymore. So that means the electromagnet is automatically switched off. So as soon as it comes over, it puts a gap in the circuit and it switches the current off. So the electromagnet is no longer magnetized. It's back to just being a bit of iron and a bit of wire. So whenever that happens, because this is no longer attracted to this, then this falls back. And whenever it falls back, it makes contact with the screw again. And whenever that happens, we get a full circuit again, which means the current can flow and the electromagnet is turned on. So this gets attracted back over. And hopefully you're starting to see how we end up with the hammer going backwards and forwards here with the gong. Yeah, it's just this constant making and breaking. That's how we would word it. The constant making and breaking of the circuit whenever the switch is pressed down. So do you know, like the switches we use in school where you have to hold it down? It would be one like that on something like this. So whenever this is being pressed down, we end up with this constant backwards and forwards between the current being able to flow and not being able to flow, backwards and forwards all the time, which means the hammer is going backwards and forwards and backwards and forwards and backwards and forwards. Okay, now we're going to write in here from our textbooks how this works, so a little bit more of a succinct description than what I just said there. Okay, a wee bit less rambly than what I said. So I'm going to write it in here, and I'll need you to pause the video and write down exactly what I write down into your notes. Okay, so here's what I need you to write in, and I'll read through it here with you. So when the switch is pushed, the current is going to pass through the solenoid, and I've just made a wee note here to make it clear that we know that that means the same as electromagnet, and the iron core is magnetized. The electromagnet attracts the soft iron armature, and the hammer hits the gong. Now all these bits are labelled up in your diagram, so this is the soft iron armature, and this is the hammer, and this is the gong. This breaks the circuit at point X, and you'll see I've drawn like a wee yellow box around that, and I did the same up here. It's just to make it clear that that is the point that I'm talking about. So this breaks the circuit at point X, and the electromagnet is no longer magnetized. The armature springs back, completing the circuit. This sequence repeats, so the bell keeps ringing. Okay, so make sure you write that in exactly as I have written mine in there. Okay, so on page 117 now, obviously I cannot show you this, I don't have one at home, but I'm going to attach a PDF of page 111 from this textbook that it's talking about on this page, and what I need you to do is to list any other uses of electromagnets that are in there, and also I would like you to do a little bit of research for yourself and write down any other uses that you can find on the internet for this. Okay, so the big thing for this lesson is knowing how an electric bell works, understanding that, and being able to write out the process of what's going on whenever an electric bell is working, and putting together our knowledge of electric circuits and magnetism. Okay, see ya.